professional courtesy, please. All right, so today's objective is to talk about exponential growth, decay, and then modeling if we have time. Like I said, modeling are just those word problems. So you will be able to model exponential growth and decay. You will be able to use logistical growth models. I'll go ahead and hand you Newton's law of cooling, and then there's another one I want you to get to. Then, of course, you're going to do some practice ones. So you'll choose appropriate models, and then you'll do exponential model base E.
Do not change.
Jaded. Thanks for closing your laptops, not having your earbuds in and cell phones out of sight. Thank you for your professional courtesy. I thought you'd be doing it like hollering it. Oh my God, I haven't had those chips in a long time.
What?
That was a throwback. Yeah, those are great.
What are they?
The lazy limon.
Oh yeah.
Throw some extra limon and some chamoy on there.
Ooh yeah.
Ay, delicioso.
Hold on. That we're the only person that watches this video, so I'm like thinking that everybody else watches them, and I'm like, wow, they just really.
We're weird.
I probably wish they were just
Like when you listen.
That's funny. I didn't think about that.
Yeah.
Well,
When I was listening to it,
we do get people like out. Like I think I've gotten people from Canada watching our videos. Like I can see which continent and stuff.
oh, that's cool.
It's not a lot, but I'm sure they're like,
Say, hey guys, welcome back to.
we're just being goofy. We're having fun. So we're good here.
Yeah.
All right, going. So let me go and write this down. And I want you to hopefully catch the joke here maybe. This is the formula for exponential growth right here. And this is the formula for exponential decay.
Huh? Wait, what? Oh, okay, I see. I see the difference.
Yes, those
They're very
are
similar.
Those are exactly right. No, they're the same.
Wait, what?
They're not similar, they're the same.
Oh.
One is exponential growth, the other one's exponential decay. Now, huh? They both have a. Well, this is just equation notation. I see what you're saying. So this could easily be y, it could be whatever you want it to be. Here's the point I do want to make though. Actually, I think I have it on the next slide, but it's kind of weird. Here's what you definitely need to know. In order for you to be exponential growth, k must be greater than 0. It has to be a positive number, right?
Yeah.
In order for it to be exponential decay,
It has to be less.
k should be less than 0, which means you have a negative number, therefore it's decaying. And that's really the difference between the two. The formula is the formula. But if it turns out that k is positive, hey, you're growing, right? And if it's negative, then you are dying.
Is that a K?
Yes.
What?
It's a cursive K.
That's a really weird cursive. I've never seen a K like that.
Are you serial?
Yeah, I always thought JR.
How do you do a K in cursive?
What's wrong with my k?
Correct.
Now I'm paranoid. I can't. I don't know. I can't stop writing this now.
It's fine. It's good. Bless you. Bless you. Bless.
Not that one. Three. It's 3.
Looks like the magic number is 3.
World record number 5. Time for it.
No, it's always 3s. So let me go ahead and show you this slide here. Again, if you have growth, k is greater than 0. If you have decay, k is less than 0.
Those people from Canada.
I wish when I was
Le voy a tirar un poco.
like in his body, but then I was like, oh, no.
Así lo voy a hacer like farmer's low. Pa. Don't try to brag. You take the phone away.
Yeah, you just see it, and I'm like, that's not funny. Yeah, that's not funny.
I can change the slide?
Yes.
Because you guys are obviously good with that, right?
Yeah.
All right, let's get started here. So let's apply this.
Yeah.
In 2000, the population of Africa was 807 million, and by 2011, it had grown to 1,052 million. Use the exponential growth model. A is equal to A naught e to the kt, in which t is the number of years after 2000. to find the exponential growth function that models the data. So we just plug and chug, people. Our formula is.
Wait, can you?
Wait.
Yeah, I want to write everything down before you can start talking.
Okay.
Wait a minute. So that's just 1,000,000,000 and 52 million, right?
No,
Wait.
52. That's a 1,000,000,000.
Oh man.
Are you taking tomorrow off?
Read it out.
No, especially not tomorrow.
Yeah, I
Why?
knew
Oh, you
times
need
was
the
like
total.
1,052
Shorter
million.
day tomorrow.
Yes, billion.
And then we have meetings tomorrow, so.
Munoz, wouldn't that be billions?
No, because then it looks shady.
Take Friday off. Treat yourself.
It looks bad when you take Friday off because you're like trying to, especially this Friday since Monday was Veterans Day.
Oh, we don't have school Sunday?
No. This is like
No, we don't have school this Monday. It's following. We have school this Monday.
well, yeah, yesterday was Monday. Friday, but I am.
All right, we're good.
I'll go out right faster.
So we have this formula. A is equal to A naught e to the kt. Do we know what we started at?
807 million.
What? Yes, 807 million. Thank you. 807 million, and it starts to grow, right? For how long?
11 years.
11 years, because it's the number of years since 2000, so that's going to be 11 years. Where do we want this formula to equal?
That one.
1,052 million.
Yeah, 1,052 million. That doesn't sound right.
So there we go. Now, if you're going to do your method, y equals this, and y equals that.
That's just good.
Okay?
Thanks.
Wait, you know what method?
Yeah, that's just good.
She's a graphical, she's a visual learner.
Sorry about that.
So at this point, guess what we're going to do?
Did you put the 11 there because of 11 years after?
Yeah, T is for time.
T is for the amount of time after 2000.
And it says right here, T represents the number of years after 2000.
Wait, so
You can't see that, I forgot, my bad. But yes, that's why it's 11. What's the first step I want to take, peeps?
Are you want to get rid of
K,
that?
so we're making a formula, and we need K as a constant. That will be that would take the, kind of when we used to do direct variation and indirect variation type thing. I loved it. What do we do at this point first? What do we do first?
Divide by 807.
Yeah, let's divide by 807. So that would give me, I'm going to leave this as this for now. E to the 11k. You guys go if I do 11k? 11k. Then what do I want to do? Introduce ln. So I'm going to, you be ln. So I'm going to introduce ln. That's gone. So now I've got ln 1052 over 807 is equal to 11k. And then finally, take this quantity and divide it by 11. That will give us our k. So now we can go back to our formula, and we can go A equals 807 e to the, what number is this? Huh?
What? LN that?
Yeah, go ln 1052 divided by 807, and then take that number divided by 0.02. That's good. Can I get a second on this?
Second.
Third? Cool.
Second or third, fourth, whatever I am now.
Are you just voting or did you verify?
Just voting.
No, you're not allowed to do that.
I did it. I got it. I got it.
Cool. All right. So, 0.0241 T. So here now is a formula that we can use when they simply say, hey, how many years in the future? If it's 12 years from now, 13 years from now, we can just throw it into that, and then we will be able to spit out A. Make sense?
Yeah, that's cool. Okay.
Like that?
Wait, so the question was asking us for the
Wait, what was the question? What was the question asking for?
Adri had a question.
Who?
Like saw this and then I saw
Oh, Adrian. I thought you said AJ. Sorry. Go.
So the original question was asking for that.
Yeah, it wants us to create a model. It wants us to find a model. And an exponential growth function that models the data. So now, if we graph this bad boy, we should be able to follow the whole thing.
Oh, it's just good.
Cool, cool, cool.
Yeah.
Cool, cool.
What?
For Cocoa Puffs.
Wait, who's
Who said they
Did I look bad?
What did what look bad?
This.
No.
In the original presentation, it took them like 4 slides that are like packed of information. I'm like, no. They would hang me. All right, you guys ready to move on? Cool. Let's try it again. The half-life of strontium, whatever that is.
That's
It's strontium 90. What is it?
It's a
chemical.
It's strontium.
yeah.
Yeah.
Chemical.
But I don't know what it is. What?
It's a chemical. It's actually it's a metal. It's a no, it's not an ion.
It's an isotope.
Oh my
No,
god.
it's an isotope. Yeah.
It's a word.
This is
It's an
chemistry
isotope.
and chemistry.
Keep going.
Anyways, the half-life is 28
I like
years,
chemistry.
meaning that after 28 years, a given amount of the substance will have decayed half the original amount. Find the exponential decay model for strontium 90. I don't even know how to say it.
Strontium.
Strontium? Is the T silent also?
How strontium?
No, it's there. Strontium.
The S.
Kryptonium.
Kryptonium, chromium, chromosome.
Stop making fun of us, chemistry kids.
No, that's cool.
Go, go, go. You can do
Oh,
it.
sorry. So, the half-life. So that means the full life. What's the next year? 56. So.
Well, then I spat it out, then I swallowed it.
Yeah, gross.
That was a bit more disgusting.
You can jump off the bridge. You're probably
Wait a second, I'm confused.
I had confusion.
Confusion of where to put things. I know the information, I just don't know where to put it. That's my seat. Yes, would the full amount, would the full lifespan be on the left side or the right side?
No, it would be on the left side because
Left side, right?
it would be on the left side because on the right side is what you start with,
Yeah.
and on the left side you wind up with half that amount,
Yeah, okay.
right?
Yeah.
Whatever that is.
So it would be. So would it be like that? Or what would that be?
So you should. Oh, after 28 years, yes. So then, yes. T is 28. Hurt. Queenie, what are you doing? Are you being unprofessional? I want to like wipe my nose well, but it hurts. Like I feel like I have scabs in here. On my only on this side. Like this side, I like. But this side, like.
I really wish we
Queenie?
could see.
Because your last name is Reina. Think about it.
Because like the dude who helped us,
No.
Do you speak Spanish?
oh yeah, so the washer's over here.
I think I got it.
That's your exponential decay model, right?
Yeah.
Okay. Let's plug in what we know. So far, I just know time, don't I?
Yeah.
It's 28 years. So this becomes, next step, let's go A is equal to A sub 0 is equal to, sorry, a little too high for me. A naught E 28K. Now, here's the deal. A naught is what I start with, right?
Wait,
But
why is
you put P.
28 your K?
Oh, I'm sorry. I don't know why. I'm gonna blame my cold. A naught is what I start with, correct? What do I want to end up with?
The full lifespan.
No, I want to end up with.
Half-life.
This is half life, right?
Oh
After
yeah.
28 years, it's half. So I'm gonna have half of A naught. Does that make sense? I don't know what A naught is. I don't know what I started with, but I know that after 28 years, I should get half of whatever A naught is. My starting amount. Go ahead.
What does A naught mean?
A naught is your original amount.
How do you say
What do you start with?
Can you say it very slowly and articulate?
A naught.
A naught.
Ah.
Oh, no.
As in not A.
So
Okay.
the number below A is part of this.
So the A with the zero there is A.
That's just think about this as a variable.
A starting amount.
It's a starting point. Yeah.
Okay, got it.
So the A and the.
This is all one quantity. This is just a variable. Yeah. Usually we just it's just called A naught. We'll because it defines time zero.
Let's just say it's.
That's why zero's there. So it's the amount when time is zero. The beginning. The starting point. Make sense?
Oh, yeah.
Kinda.
So this is all we have. That's what we get to work with. You guys ready?
No.
Yay. No? I'm gonna try to get rid of A naught here. I'm gonna multiply by 1 over A naught. I can do that, correct?
Yeah.
As long as I
Do it to both sides.
do it to the other side. So this is 1 over A naught. This will make 1. And
That will make
this will
two.
make 1. So I end up with 1 half, which kind of makes sense, doesn't it?
Yeah.
E to the 28K.
Okay.
How do I get rid of E?
Ln.
I ln. So ln, I've got ln half is equal to 28K.
Damn, I think it's backwards.
Divide both sides by 28, and K will be this quotient.
I got the opposite of that,
And it's approximately error.
it's approximately negative 0.0248.
Excuse me.
I did the
Approximately negative.
Negative
point 0.0248. It'll be 2.4. It'll be 2.4.
I'm just gonna go 0.0224. Now, is this a reasonable solution for K? What?
It would be 5, wouldn't it? Because
Okay,
it's 7.
God, Jesus.
Don't want to get it wrong.
Okay. Yes. Is this an acceptable response for K?
Yeah.
No.
No, because.
Because it's a I don't know.
Well, it's exponential decay. What did we
Okay,
say
so
about?
yeah.
Oh yeah, so yeah.
Yes, yes, it is.
Yes, then
Right,
it is.
because it's decay. K should be negative, so it looks kind of.
that.
That's a good way to verify right there. If it turned out positive, then you fools. You're wrong.
That's a growth.
You just lost points.
So wait, it would be like it's so it's gonna be A is equal to A naught and then negative 0.025 times
Right.
20.
So if we were going to make our model, then we would have A is equal to A naught e to the negative 0.025
OT.
time.
Got it.
And then all we would need to know is the amount you start with, and then how long it's going to take to decay.
For a second, I thought you were being sarcastic.
No, she got it. You could see the lights in her.
She's just like shining.
Sun is shining,
Stop.
This is the first time in the whole year.
weather is something. No, that's a Bob Marley.
Bob Marley song. You still have Thanksgiving in
I
there
hate
though.
Thanksgiving.
Fine, you can just eat as much as you want.
Thanksgiving food is stressful.
Ah, Dios mío. Can we move on?
Yeah.
Let's move on.
Argue about Thanksgiving and Christmas.
Get this formulas down. This is mathematical model for limited logistical growth. I think so. Let me try my magic marker. that work?
Is that an E or a C?
That's a C.
C at the top.
C at the top.
What is that called?
Limited logistic growth.
This is limited logistic growth.
Wait, this is growth?
Limited logistic growth.
Yeah, write it down. Limited logistic growth.
I like these. I have a bunch of these. I'll bring another one tomorrow. Black out.
A, B, and C are constants. C must be greater than 0. Otherwise, if it's 0, then the whole thing is just wrong. Right? 0 in the numerator just makes the whole thing 0. So it's obvious. It's an obvious.
You have to be greater than 0.
A, B, and C are constants,
No, but C and B.
but C can't be 0.
Wait, C?
C has to
No,
be
because if 0 is in the numerator, then all gone.
Is there anything for any of the bottom ones?
As long as they're constants. Can I close this?
Yeah.
So here, see? A, B, and C are constants. C has to be greater than 0, and B has to be greater than 0.
Are you staying after school today?
Yeah.
Okay. Because I came in here yesterday and you were gone already.
Yeah, they called. I forget there was a meeting. And then Mr. Rosso, I heard, had a family emergency, so he couldn't stay either. Okay, you guys got this formula?
Hold on.
Got another formula for you. Actually, a couple more formulas.
I have to write down one thing.
Here I am.
Okay, you're good.
My allergies are so bad right now. I forgot to take an allergy.
Me too.
Didn't you take one yesterday? Oh, you left, huh? A couple of people that went came in. Good? All right, here you go. Next one. This is the, what did I tell you this was called?
Cooling.
Newton's law of cooling. This one's Newton's law of cooling. Because you're going to need it for some of those problems. Here, I'll write it bigger for you. I mean, copy it. Oh, I can't reach that.
You like this. Try and jump as high as possible.
Here you go, Sunny Low. Is that good? Yeah? C is the constant temperature of surrounding medium. T naught is the initial temperature of the heated object, and K is a negative constant that's associated with the cooling object. You got a C?
I go to sneeze and it's not coming out.
Pineapple. Barbara Streisand?
That makes
Michael Jackson.
that makes you not sneeze. You want to sneeze.
Oh, you want to sneeze? Want some pepper? Jack you up. Yeah, I I did that this morning. I felt really dumb because I like eggs. I like black eggs. Anybody ever have black eggs?
Black
Black
eggs.
eggs.
What the heck?
So you have your eggs and then you put so much pepper on it that it looks black.
Oh,
And then I went to smell it. It's like, okay, that was a mistake. Jacked up my nose.
You put a lot of pepper on your eggs.
I do.
Want to know what's good with your eggs? This is how you should make it. Milk. Add, of course, you have to add milk.
I don't scramble my eggs.
You don't scramble your eggs?
I do.
Okay, well, if you did, but even if you don't put any other seasoning but garlic.
Garlic salt?
Try it. Just try it.
gross.
Come back and let me know.
Hold on.
All right.
And parsley.
Yeah, and parsley.
Oh, parsley is good. Okay.
Wait, I didn't get it down.
Sorry. You look comfortable there.
Oh, is it, I should have wrote it down.
You're working, so it's fine.
How many more slides do we have?
Like
I think there's 2 more, 3 more, 4 more.
You said 2,
3.
3. Because we have that.
Remember that time?
We can switch sides now.
Okay, there was like part 1, part 2, part 3, part 4.
Okay, you guys ready?
Yeah.
An object is heated to 100 degrees Celsius. It is left to cool in room temperature, in a room that has a temperature of 30 degrees Celsius. After 5 minutes, the temperature of the object is 80 degrees Celsius. Use Newton's law of cooling to find the model for the temperature of the object T after T minutes. Okay, go.
Wait, we did this in chemistry.
Go chemistry.
Did we? Copy the Yeah, we did. Chemistry's like half of another math class. I'm sorry.
Hey, look, you just learned something, right? Which one is the initial temperature?
100 degrees Celsius.
In the formula.
Oh, T naught.
T naught. Yes, T sub 0. Good.
So isn't that where 100 is?
That's 212.
The original temperature.
Yeah.
Do you need me to make this bigger? You already have the formula, right? Sonny? Okay. Yeah, the letters, I don't know if I can do that.
C is the constant, right? Is the constant temperature, which would be 80 degrees. 80
That's about it.
plus 100. I have no idea. I think it's obviously it's in December, but
Wait a minute, which one did you say was constant?
would it be the 80 degrees or would it be the 30?
No, the room is constant temperature.
So it would be the 30.
Right. The room is at a constant temperature of 30. The 80 was a result of the cooling.
Okay. E and then we're looking for T, right? What's K? K is the negative constant associated with the
C is the constant temperature being applied.
So K would be the 80, right?
K is the coefficient, the constant coefficient you're looking for, and not the constant C, but the value K.
Okay.
I wish there was some price you could pay, like, to get out of something. Like, if I don't want a cold, like, maybe I can stub my toe really hard, and
Dude,
you know what I mean, like,
I
pay a
would
price.
do that. I've broken my toes so many times.
I
Like,
didn't say break it. I said I would rather live 2 weeks than to have
like
that.
I would just break this toe over here because like I can't feel it anyway. No, I have nerve damage, so like I can't feel it, and if I do, it just feels like it's on
The
fire.
nurse is like, wow.
Never mind. I'm gonna just come deal with my cold.
Yeah.
Ugh.
We're
That's
just like,
horrible.
wow.
No, seriously, like I'll sit there like stab at things sometimes. Just like I can't feel it.
Oops.
Lily, chill.
I know. Commentate. Commentate, Lily. Commentate.
Yeah.
What
Wait,
time was
wouldn't
it?
K would be 80, or no, but would K be, or T we don't have a
It was
after
5
5 minutes.
minutes.
T is 8,
Oh,
right?
T in minutes. T
No,
minutes.
T minutes and 5.
Yeah, I know that.
So after log, we get T is equal to 30 plus, what the freak? This is gonna get you back to 100. Subtract that 30, you get,
Minus 30 plus
70, K,
I don't know. Which is my way or my way?
This is ln 50 divided by 70, and then that quantity is divided by 5. Okay. All right. I've got another formula for you. You guys ready? And you kind of want this one, and when you see it, it'll make sense to you, hopefully. So it's expressing an equation that is y equals a b to the x with a base of e. Yeah, let me rewrite this again for you. So y equals a b to the x can be rewritten as y equals a e to the ln b times x. You guys see what they did there? All they did is introduce a 1.
Yeah.
Because e and ln are kind of inverses of each other. But now you can introduce e in a different way. Right?
When expressing.
Sometimes you will need to do that so that you can get that exponent. Remember that whole exponent rule? You can kick to the front. That would becomes linear, not linear, but no exponents type thing.
To y equals a.
With this method, I can't take this and put it up front. But because now I have this, now I can take that and take it to the front.
You do the e and the ln, since it's the ln b, what would happen?
Well, you'll have some values to plug in there. I'll see if I can get this one in real quick so you can see that. So they want you to rewrite this and express the answer in terms of natural logarithms and round it to 3 decimal places.
Y is equal to 4.
Yeah?
I can't do my exit ticket
And no,
for
it's
decimal.
That's okay, don't worry about it.
So it'd be y is equal to a, which is 4. Oh wait. 57.48. They apparently guessed that.
I'm going to go ahead and stop this real quick because